All right, we are starting on page 45 today. Page 45. We're going to finish up this last little bit of section 3.7. You're going to need your calculator. If you don't have your calculator close by, please pause this video and go get your calculator and then come back. Seriously, you need a calculator. You need to do some of this with me so that you understand the button pushing. All right, again, because math is wonderful, no matter which way you do a problem, as long as it is mathematically valid, you get the same answer. So we're going to look at another problem today, and in a slightly different way. We've got two separate equations here. One quadratic, that's going to be a parabola, and one linear equation. And we're going to look at trying to find how we solve this system of equations. A system of equations is two equations with two variables for our purposes today. Two equations with two different variables, specifically an x and a y. All right, recall, Carlos likes to use a table. Zach likes to graph. Clarita likes to factor. Tia likes to complete the square. And Tahani likes quadratic formula. And we are going to look at solving this system of equations in those 5 different ways. All right, Carlos and Zach like to put it in the calculator, so let's go ahead and grab your calculator, which is close by because you went and got it when I asked you to. And we're going to go ahead and enter these two equations into y1 and y2. So go to y equals, in y1 we'll put in x squared minus 4x plus a 1. And in y2 we put in x minus 3. All right, Carlos likes the table. I'm just checking my table set. I'm going to start, so I went to table set, which is second window, and I want to start it at 0. Delta table is 1. And now when we go up to table, up here, we have 2 columns for y. And in this case, we don't want to look for zeros in the y. We actually want to look for when the two y values are exactly the same. So when we look at the table, we're looking for the same y values. So let's look through, and right here when x is 1, we have a -2 and a -2, so that's good. And is there another one where we have the same y values? Oh, right there. When x is 4, y1 is 1 and y2 is 1. So we'll copy a portion of that table. We have x, y1, and y2. And again, we saw the same y values when x was 1. When x is 1, y1 was -2 and y2 was -2. Also, when x is 4, y1 is 1 and y2 is 1. This tells us the solution here is x equals 1 and x, sorry, I'm losing my voice, I think. When x is 1, the y values are -2, and when x is 4, the y values are 1. So it gives us ordered pairs now. Our solution is going to be ordered pairs. So we're going to have 1, -2, and also 4, 1. That's the solution. The solution to a system of equations is an ordered pair. Sometimes there's more than one, so ordered pair or pairs. In this case, there are two solutions. If we look at Zach's strategy, Zach likes to graph, so let's go back to the calculator. And let's hit zoom 6 to get a nice standard viewing window. There's the quadratic parabola, and there's the line. And we're looking for points of intersection here. So those 2 points right there. So we're going to use the calc menu. So second trace, and then intersect, because we want points of intersection. And again, just like for zeros and for a maximum and a minimum, the calculator is going to ask you 3 questions. So we're going to go to number 5, and we're going to find this one down here, this one that's on the left first. And when we find that, the calculator is asking you first curve. Is this the first curve? And this is what it's asking you. This y1, is that the first curve? Yes, so you hit enter. Now it's asking you, is this one, y2, which was x minus 3, is that your second curve? Yes, so you hit enter. And then it's asking you to make a guess. And the reason it wants you to make a guess is it needs to know which one do you want the calculator to find. Well, we're finding this one on the left first. So I'm going to arrow a little bit closer. Just close. It doesn't have to be dead on, but close, and then hit enter again. And it gives us that intersection at 1, -2. Let's go through that process again and find this point of intersection over here. So when we do that, again, the calc menu, intersect. Calculator again asks you first curve. It doesn't really matter where the cursor is if you're looking up here, and it's y1, so yes, hit enter. And then the second curve, that's this one, y2, so hit yes for enter. And then it asks you to make a guess. Now right now my cursor is pretty close to that first point of intersection. We want to move that cursor over here to this second point of intersection. So we'll go right over there, close by, hit enter for yes. And there's our second point of intersection at 4, 1. And as before, same answer, because we know as long as we do something mathematically valid, we're going to get the same answer every time. All right, Clarita likes to factor. So what we see here is even though these have subscripts on them of y1 and y2, they're both y equals. So since these two are both y equals, we can set these two pieces, these x parts, equal to each other. So that'll give us x squared minus 4x plus 1 equals x minus 3. We can't factor right now. Can't factor until one side's equal to 0. So let's subtract this x from both sides. That's going to give us x squared minus 5x. And let's add this 3 to both sides. It'll give us a plus 4 equals 0. And we can go ahead and factor at this point. So setting this up, we have x and x. Two numbers that multiply to be a positive 4, add up to be a negative 5. And that's going to be a minus 4 and a minus 1. And we separate, x minus 4 equals 0, or x minus 1 equals 0. Solve this equation by adding 4 to both sides. X is 4. Solve this equation by adding 1 to both sides. X equals 1. So again, that only gives us the x values. So we're going to have to go back. I'm out of space down here. I got to come down here. And we have 4 comma something and 1 comma something. Yes, I know you know what those y values are, but how are you going to get this if you don't have a calculator and you didn't, or they didn't come out nice? We're going to take this x value and plug it back up here into one of these equations. Doesn't matter which one, I'd probably choose the easiest one. Why don't we use this one, y2? So plug a 4 in. 4 minus 3 is 1. And same thing, take this 1 and we'll plug that 1 back up in here. And we have 1 minus 3, which is negative 2. And there's your ordered pairs. Tia likes to complete the square. Well, Tia's going to have to start off the same way that Clarita did. We're going to have to set the two pieces equal to each other. And then get everything on one side. So let's, again, add this x over, subtract that x. It's going to give us x squared minus 5x. Add that 3 plus a 4 equals 0. And then we're going to look at this and we're going to decide really is this a nice setup to do completing the square. Leading the coefficient of the x squared is 1, which is good, but this coefficient of the x is odd. That's not so nice. So we're going to say that, okay, Tia, you like completing the square, have at it. We're not going to do completing the square because that's odd, and we want that to be even in order to complete the square. So we're not going to do this. We need that to be even. So we're not going to do completing the square process. Tahani's strategy with quadratic formula. We're going to have to start just like Clarita did and just like Tia did, and we're going to have to get that into that x squared minus 5x plus 4 equals 0 situation. And now we can plug through the quadratic formula. X is opposite b, so 5 plus or minus b squared minus 4 times a, which is 1 times c, which is 4, all over 2 times a. We'll have 5 plus or minus 25 minus, oh boy, 4 times 1 times 4, 16, all over 2. And cleaning this up a bit, this is going to give us 5 plus or minus 25 minus 16, that's 9, all over 2. I'm sorry for the lack of space here again, although it's not my fault. This is going to give us 5 plus or minus the square root of 9, which is 3, all over 2. No radicals, so we can separate this. And we have 5 plus 3, which is 8 divided by 2, or 4. And then we also have 5 minus 3, which is 2 divided by 2. X is 1. And then by the same process that Clarita did over here, we'll take the 4 and the 1 and plug it back into the original equation, and we will get 4, 1, and 1, negative 2. All right. Okay, please turn the page and navigate yourself to page N48. Navigate yourself to page N48. And we just got done solving quadratic equations and linear equations, a system. I'm going to try and refresh your memory on solving a system of 2 linear equations. Now, you did this last year in Math 1, but I just want to refresh your memory. So I want to review solving a system of linear equations. So just a couple minutes ago we did a quadratic and a linear, and now we're going to do 2 linears. And there's 2 ways we're going to review here. The first way is when we have something like this. 3x plus 4y equals 7. And we have x minus 9y equals 23. When we look at this system of equations, sometimes they put those braces here to group those two equations together. We don't have this set up as y equals and y equals. What we do have, though, is the variables and the numbers lined up. So we have the 3x and the x, the 4y over the 9y, and the 7 and the 23. And what we're looking for to do here is to multiply one of these equations by something so that when you add it to the other one, it makes one of those variables cancel out. Let me say that again. We're going to multiply one of these equations by something so that when you add it to the other one, it makes that one of those variables cancel out. What if we took this bottom equation down here and we multiplied by a negative 3? Well, this first equation we're not going to do anything with. It's going to stay the same. So we have 3x plus 4y equals 7. This bottom equation, if we multiply by a negative 3, that gives us a negative 3x, and a negative 3 times a minus 9 is plus 27y, and a negative 3 times a positive 23 is negative 69. Now watch what happens when we go ahead and add those two equations together. 3x plus a negative 3x, that's 0x, that's gone. So that canceled out. A 4y and a 27y, that's 31y equals, and then over here, a 7 and a negative 69, that's negative 62. Now solving for y, we can divide both sides by a 31, and that gives us y equals negative 2. Once we have y equals negative 2, then we're going to take that y equals negative 2 and plug it back into one of those equations. It makes no difference which equation you use, one of the original equations. You just pick one, substitute in y equals negative 2, and then solve for x. I'm going to use the top equation. That's going to give me 3 times x plus 4 times y, which was negative 2, equals 7. Now I have 3x, and a 4 times negative 2, there's minus 8, equals 7. Add the 8 to both sides. We have 3x equals 15. Divide out the 3. X is 5. So our final solution here, the answer, is this ordered pair. 5, negative 2. That's the answer. There is only one answer for lines, a system of linear equations, because if you think about it, two lines crossing, they intersect at 1 point. So you're only going to get 1 point. All right, let's take a few minutes here and let's look at another situation. This situation is very similar to the one that we just looked at with the quadratics. Let's use this. Y equals 6x minus 14 and y equals negative 5x plus 19. And what's very similar about this that was with the quadratics and the line is that both of these equations are equal to y, which means these two pieces are equal to each other. So we have 6x minus 14 equals a negative 5x plus 19. Solving this system, I'm going to add 5x to both sides. I'm sorry, not solving the system, solving this equation. Add 5x to both sides. That's 11x minus 14 equals 19. Now I'm going to add 14 to both sides. That'll give us 11x equals 33. Divide by 11. X is 3. And again, once we have x is 3, then we're going to take that x equals 3 and plug it back into one of these equations. Doesn't matter which one. I'm going to use the top one here. And we're going to have y is 6 times 3 minus a 14. 6 times 3 is 18 minus 14. Y is 4. Final answer here then is an ordered pair. 3, 4. X, Y. 3, 4. All right. For tonight, your homework is, okay, so you took the quiz today in class. So today your homework was to watch this video and then to do page 48, 15 through 19. And I'm going to give you a little hint over here. It says number 16. So when you do that, the answer is an icky fraction. Just so you know, as you're working through it, you're not going to get a nice number for that one. It's a fraction. I'll even tell you what the denominator of the fraction is. The denominator is 7. That way you know if you're getting kind of if you're on the right path. All right, thank you very much. See you tomorrow.